Welcome to today's Triple Z. The Triple Z Podcast is a daily recording that you can use to help you fall asleep each night. Just turn down the volume, lay back and enjoy as you fall asleep. Today we are traveling back in time to 1928 and learning about the Monroe Adding Calculator. This is a mechanical calculator from the days before modern computers. This book is designed to enable even inexperienced operators to use the Monroe Adding Calculator to the best advantage. The instructions are made extremely simple so that they will be understood by beginners who may never have used an adding or calculating machine, and enable them to add, subtract, multiply, divide, and work out all ordinary commercial problems without other assistance. Part 1 gives instructions for performing the fundamental arithmetical operations: addition, subtraction, multiplication, and division, with rules for handling decimals. Part 2 describes easy methods for solving certain types of problem and the use of various shortcutting operations. Examples are given to show the wide adaptability of the Monroe and its effective application to modern office figuring work. No attempt, however, is made to describe all of the many uses of the machine, which will handle any kind of figure problem regardless of how complicated it may be. Further instructions in the use of the Monroe and its applications to special lines of work will gladly be given if you will get in touch with either the nearest local Monroe office or write to the general offices of the company at Orange, New Jersey. Copyrighted 1928 by Monroe Calculating Machine Co., Inc. The easiest and most natural manner of operating the Monroe is as follows. Place the machine on the desk directly in front of you, turned at a slight angle. Use fingers of right hand to depress keys. If the amounts are large, both hands may be used to set the figures on the keyboard. With the right hand, operate plus and minus bars and dials clear out crank. Left hand is free to follow work and to operate carriage shift lever. The dials clear out crank needs but one turn in either direction for clearing. Always complete either the forward or backward revolution of the clear out crank to the bottom of the turn. Various parts of the machine and their operation. The Monroe Adding Calculator, as its name implies, is an adding and calculating machine capable of performing the four fundamentals of arithmetic: addition, subtraction, multiplication, and division, with accuracy, speed, and simplicity. It may best be described briefly in a manner for easy understanding by mentioning its three principal parts: a standard keyboard for setting up the numbers to be added, subtracted, multiplied, or divided, the plus and minus bars, or crank in hand model, at the right of the keyboard for performing the operations, and the carriage at the top of the machine holding the dials which register the results and proofs of the various operations as they are performed. The Monroe is manufactured in three distinct models: the Series 0, 1, and 3, all operating under the same basic principles of a forward movement for addition and multiplication, and a reverse movement for subtraction and division. On the electric models, addition and multiplication are accomplished by use of the plus bar, subtraction and division by use of the minus bar. Any electric model Monroe may be operated with the same ease as any hand model by the insertion of the hand operating crank. On the hand models, the operations are performed by use of the hand crank, conveniently located at the right of the keyboard, a forward turn for addition and multiplication, and a backward turn for subtraction and division. The principles of operation are the same for all models of Monroes. To illustrate the operation of the Monroe in the following instructions, the model CAL 163 has been used. These instructions, however, are applicable to any other Monroe model. If learning to operate a hand model, these instructions should be followed out in the same manner, excepting where reference is made to the plus bar. The hand operating crank must be operated in a forward turn, and where the minus bar is referred to, the crank must be operated in a backward turn. Complete forward or backward turns of the hand operating crank should always be made, otherwise the machine becomes automatically locked to guard against operating errors. The stopping place, or neutral position of the crank, is designated by an arrow on the right of the keyboard opposite the crank. In the following descriptions of the parts of the Monroe, the numerals refer to the key numbers on page 4. Keyboard. The Monroe keyboard is the standard flexible type. By depressing the keys, amounts to be added, subtracted, multiplied, or divided are set up. The depressed keys enable the operator to read the amounts as they are set up. An error may be detected and corrected immediately by simply depressing the proper key. This operation automatically restores the key which has been incorrectly depressed in the same call. Plus and minus bars. The plus bar is used for the forward operation of the machine as in addition and multiplication. The minus bar is used for the reverse operation of the machine as in subtraction and division. Carriage. The carriage may be moved to right or left as required. The figures in the dials are always in vertical alignment with the figures on the keyboard. Thus, a depressed key in any column will operate the dial and the carriage directly above it. Carriage shift lever. The carriage may be instantly shifted to the left or right as desired by a half turn of the carriage shift lever. If it is desired to shift the carriage a number of places, it may be raised by the hand shifting knob on the right end and moved the number of spaces required. Upper dials. The upper dials show the multiplier in multiplication and the quotient in division. In the Series 0 and 1 models, there is a single set of upper dials that register multipliers in black figures and quotients in red figures. In the Series 3 models, there are 2 sets of upper dials, the right upper dials registering in black figures only and the left upper dials registering in black and red figures. The right upper dials register multipliers. Having a tens carry mechanism, they permit shortcut multiplication and serve as an item count in addition. The left upper dials register multipliers in black figures and quotients in red figures. Combinations of both black and red figures are used in special work. Single multipliers or quotients may be registered in left upper dials and accumulated multipliers or quotients in right upper dials. Both sets of upper dials operate simultaneously. Lower dials. The lower dials show the result in addition and multiplication, the remainder in subtraction, and the dividend in division. Dials clear out crank. A forward turn of the dials clear out crank clears the upper dials, and a backward turn clears the lower dials. Upper dials control lever. In the Series 3 models, both sets of upper dials clear simultaneously unless the upper dials control lever is pushed to the left position, when the left dials only clear and accumulated amounts remain in the right upper dials. Decimal markers on dials. These movable markers are set in advance for the number of decimal places required for the work in hand. Decimal markers on keyboard. These markers between the columns of the keys are turned over by means of knurled knobs, showing white to indicate the position of the decimal point on the keyboard. Like those on the dials, they have no mechanical connection with the working parts of the machine, being used simply as an aid to distinguish the location of the decimal points. Repeat and non-repeat keys. When the repeat key is depressed, the figures set on the keyboard remain locked until cleared by the operator. When the non-repeat key is depressed, the keyboard clears after one revolution of the machine. Repeat key must be depressed when performing multiplication and division. Zero keys. The zero keys clear any column of keys without disturbing the setup in other columns. They also assist the operator in seeing at a glance in what columns figures are set. Clear key. Depressing the master clear key clears the entire keyboard and depresses all zero keys. Upper dials reversing lever. On the Series 3 models, when this lever is pushed forward into position, the direction of rotation of the upper dials is reversed. It is only used in involved calculations and for ordinary work should be kept in down or X position. Item counter. In a series of additions on a Series 3 model, the number of items added appears in the right upper dials. On Series 0 and 1 models, when the item counter is turned to the right, with arrow pointing toward the keyboard, the one key in the last column is held down and the number of items added is counted in the lower dials. Above this one, the operator should guard against having this item counter hold down the one key in performing other operations. Motor. The Monroe Electric is equipped with the automatic start and stop motor. When operating the machine, the motor switch is turned on, although motor only runs when the plus or minus bar is depressed, making an electrical connection. Addition. Though addition may be accomplished with the carriage in any position, it is best when performing the simpler operations to have the carriage shifted to the left as far as it will go, as shown in Figure 2. Addition is best accomplished by the locked figure method, that is, with the repeat key depressed. Example: 325 plus 456 plus 222 equals 1003. Set 325 on the keyboard and touch the plus bar. The machine makes one revolution, and the 325 appears automatically in the lower dials. Set 456 on the keyboard, touch the plus bar, and the 456 is added to the 325 in the lower dials. Set 222 on the keyboard and again touch the plus bar, registering the result 1003 in the lower dials as shown in Figure 2. Right upper dial shows a 3, the number of items added. When familiar with this principle of operation, the operator should practice the method of Monroe shortcut addition, simultaneous depression of keys, and plus bar. The figures to be added are set on the keyboard with the fingers of both hands, and at the same time the plus bar is depressed, the amount registering instantaneously in the lower dials. Thus the necessity of having to make the key depressions first, and then depressing the plus bar as a separate operation is eliminated. Subtraction. On the Monroe, subtraction is a direct operation. The larger number is set on the keyboard and turned into the lower dials by a touch of the plus bar. Next, the smaller number is set on the keyboard. A touch of the minus bar causes a reverse revolution of the machine and the smaller number is subtracted, the difference showing in the lower dials. Example, 1003 equals 678. At the end of the example, in addition, 1003 appears in the lower dials. To subtract 325, simply set 325 on the keyboard and touch the minus bar, and the answer 678 appears in the lower dials. Subtraction is also performed by reversing this process, i.e., first, with the dials cleared, the smaller number is subtracted from 0, then the larger number is set on the keyboard and added. Multiplication. Multiplication on the Monroe is as simple as addition. It is accomplished by setting one number on the keyboard and writing the other number in the upper dials by means of the plus bar. Example, 789x 234 equals 184,626. Set up 789 on the keyboard as shown in Figure 3. Hold the plus bar down until the machine makes 4 revolutions and 4 appears in the upper dials. With the carriage shifting lever, shift the carriage one position to the right. Hold the plus bar down until the 3 appears to the left of the 4. Then shift the carriage again to the right. Hold the plus bar down until the 2 appears to the left of the 3. The keyboard and dials are now in the position shown by Figure 4. At the completion of the example, the right upper dials read 234, the multiplier, the lower dials, the answer, 184,626, and the keyboard the multiplicand, 789. This is a complete and positive proof of accuracy. Notice as these operations are being performed that the multiplier always registers in the upper dials directly over the arrow on the keyboard. Keep this in mind, as it is this point that determines how the carriage must be shifted in order to register the digits of the multiplier in their proper positions. For simple multiplications on the Series 3, read the multiplier in the right-hand upper dial. In multiplying, if the plus bar is held down too long and a number that is greater than the desired multiplier appears in the upper dial, hold the minus bar down until this figure is reduced as much as necessary to make it the correct number. Similarly, if a figure of the multiplier in the upper dials is found to be less than the desired number, due to not holding the plus bar depressed long enough, depress the plus bar again until this figure is increased as much as necessary to make it the correct number. In other words, if it is discovered that the wrong number of revolutions have been made at any step, it shows in the right upper dials and may be immediately corrected by either forward or backward revolutions, as the case may require, without doing the problem over. Changing the multiplier. Suppose you wish to change the multiplier from one number to another, leaving the multiplic 789 constant on the keyboard. For instance, 789 is also to be multiplied by 432. Do not clear machine and begin over again. Simply change the 234 to read 432 by changing the 2 to read 4 by means of the plus bar. Shift the carriage 2 places to the left, and with the minus bar, change the 4 to read 2. As this is done, the figures in the lower dials change correspondingly. The result in the machine, ignoring the left-hand upper dial, will read as follows. The entire operation is extremely simple. It requires no expert knowledge, skill, or training, and you know your result is absolutely accurate because all the numbers you have used are visible in the machine. Multiplication on the Monroe may be performed in either direction. For example, in the above multiplication 789 times 234, you may begin as explained by multiplying first by the 4 units in the multiplier, shifting the carriage to the right to put in the 3 tens and the 2 hundreds, or you may begin by turning in the 2 hundreds in the third position in the upper dials, shifting the carriage to the left to put in the 3 tens and the 4 units. The result will be the same in either case. As long as the multiplier reads correctly, the answer is bound to be accurate. Division. On the Monroe, division is performed with the same ease, simplicity, and directness as multiplication. As multiplication is a process of continued additions and is accomplished by the use of the plus bar, so division is a process of continued subtractions and is accomplished by the use of the minus bar. 12. Example, 477,591 224 equals 2132, remainder 23. Set the dividend, 477,591, in the keyboard and with one touch of the plus bar register it in the lower dials. Clear the upper dials and keyboard. Set the divisor, 224, on the keyboard and shift the carriage 3 spaces to the right so as to bring the divisor, 224, directly under the 477 of the dividend, the first position for dividing. The machine at this point is as shown in Figure 5. Hold the minus bar down until the machine stops, then touch the plus bar. The red 2 in the left upper dials indicates the first figure of the result, as shown under the first step on the next page. Shift the carriage 1 space to the left again. Hold the minus bar down until the machine stops, then touch the plus bar. The result will be a red 1. See second step. Continue this operation with the minus and plus bars and the shifting. At the completion of the problem, the quotient 2132 will appear in the left upper dials and the remainder 23 in the lower dials. The whole operation requires but 3 or 4 seconds. In simple division, ignore the figures which appear in the right upper dials. If operating a hand machine, and at any stage of the division, too many backward turns of the crank are made, a row of 9s is brought up at the left of the dividend, and a bell rings, instantly indicating the extra turn. To correct this, merely turn the crank forward, bringing all the figures back just as they were before the extra turn was made. Again the bell rings, indicating that the correction has been made. Shift carnage to left and continue division by subtracting. Multiplication of decimals. The arrangement of the dials and the keyboard in the Monroe machine makes it particularly adapted to the handling of calculations involving decimals. The use of fixed decimal points is strongly recommended for all work of this kind. By the use of fixed decimal points, we reduce the whole matter of multiplying decimals to one simple rule, the ordinary arithmetical rule for handling decimals. That is to mark off as many places in the result as there are decimal places in the other two factors combined. On the Monroe machine in multiplication, the result dials are the lower dials and the two factors are shown in the upper dials and the keyboard, respectively. Hence our rule as applied to the Monroe machine for multiplication of decimals would be as follows. First, having determined from the given factors the greatest number of decimal places that must be provided for, fix the decimal points on the keyboard and on the upper dials with a sufficient number of places to accommodate those factors. Then fix the decimal place on the lower dials at the sum of the places as they have been fixed on the upper dials and keyboard. Always keep this balance in decimal places. Remember it as a formula for decimal points as follows. Upper dials K keyboard equals lower dials. That is, the number of decimal places on the lower dials is always the total of the decimal places on the upper dials plus the decimal places on the keyboard. Then proceed with the multiplication, being careful to set the multiplicand on the keyboard with proper relation to the keyboard decimal point as it has been fixed. Shift the carriage if necessary to such a position that when the multiplier is being turned into the upper dials, it will be registered in the proper relation to the upper dials decimal point as it has been previously fixed. You can then be sure without question that the result as it appears in the lower dials will be properly pointed off by the fixed decimal point which has already been established on those dials. Example, 20.125x.425 equals 8.553125. In this problem, the largest number, 20.125, or the multiplicand, is to be set up on the keyboard. This means that we must mark off 3 decimal places on the keyboard to accommodate it, turning over marker between the third and fourth columns of keys. The .425 is to be turned into the upper dials. Therefore, 3 places must be pointed off on the upper dials to accommodate the multiplier. We now have 3 places pointed off on the keyboard and 3 places pointed off on the upper dials. We must, therefore, fix the decimal slide on the lower dials at the sum of 3 and 3 or 6 places. Set up the 20.125 on the keyboard with proper relation to the keyboard decimal point. Shift the carriage as may be necessary and hold the plus bar down so as to register the 5 and 2 and the 4 of the multiplier in the upper dials in the proper relation to the fixed decimal point which has been established there. The result will then show as in Figure 7. Figure 7. Division of decimals. In division, the same principle of pointing off applies. That is, the sum of the decimal places on the upper dials and the keyboard must always show on the lower dials. Example, 22.8686.7 equals 3.4131. Quotient is desired to 4 decimal places. Since the quotient is going to be shown in the upper dials and is to be carried out to 4 decimal places, we start out by fixing the decimal point on the left upper dials with 4 places to the right. The divisor, 6.7, is going to be set up on the keyboard. Therefore, we need to use but 1 decimal place on the keyboard. Suppose, however, that we decide to leave the decimal place fixed on the keyboard at the same place it was in the previous problem, that is, with 3 places to the right so as to accommodate any divisor containing from 1 to 3 decimal places. This means that having the decimal point fixed at 4 places on the upper dials and 3 places in the keyboard, it must be placed at the sum of 4 and 3 or 7 places on the lower dials. We must now get the dividend into the lower dials. To do this, set the dividend, 22.868, on the keyboard and turn it into the lower dials with a touch of the plus bar, so that it shows in the lower dials properly pointed off as shown in Figure 8. As the dividend is turned into the lower dials, a 1 is registered in the upper dials. Always clear this 1 from the upper dials before proceeding with the division. The easiest method is first to clear the keyboard by means of the master clear key, then touch minus bar so that machine makes one reverse revolution. See speeding up division on page 20. Set 6.700 on the keyboard and shift the carriage to the proper position for the first subtraction. See figure 8. Continue the operation as in simple division previously explained by holding the minus bar down until the machine stops. Touch the plus bar and shift the carriage toward the left. As the result is being registered in red in the upper dials, it will automatically register with proper relation to the decimal point which was previously fixed, and the final result will show as in figure 9. The 0.002300 shown in the lower dials is the remainder. Take another example. 20.6216.41356 equals 3.21521. Quotient in this example is to be carried out to 5 decimal places. This means we must point off 5 places on the left upper dials, as that is the place where the quotient is going to appear. Since the divisor, 6.41356, must be set up on the keyboard, we must mark off 5 places on the keyboard. Now with 5 places on the upper dials and 5 places on the keyboard, we must point off the sum, or 10 places on the lower dials. Set 20.621 on the keyboard. Turn it into the lower dials in the proper place with regard to the decimal point as shown in figure 10. Clear the keyboard and do not forget to clear out the 1 in the upper dials after turning in the dividend. Set 6.41356 on the keyboard as indicated and shift the carriage to the proper position to start the division as shown in figure 10. Proceed with the division in the regular way, showing the final result as in figure 11. Special problems and rules for simplifying and shortening certain operations. The simplicity of the Monroe and the flexibility of every feature make it readily adaptable to a number of shortcuts in the various operations of multiplication and division depending upon the character of the particular problems. We are giving herewith some of these rules. Others of a special nature, depending upon the character of the work that is being done, will be quickly picked up by the operator, or will be suggested, upon request, by the Monroe department which is maintained for that purpose. Correcting figures in the lower dials. If after a number has been turned into the lower dials it is noticed that 1 or 2 figures are incorrect, it is not necessary to clear out all the lower dials to make the correction. Simply leave the incorrect figures on the keyboard, touch the minus bar, subtracting them out, and fill in the correct figures on the keyboard. Much time in correcting errors may be saved in this way. Another feature of Monroe efficiency. Transferring figures from lower dials to keyboard. In transferring an amount from the lower dials to the keyboard, especially if it is a large one, it is well after setting the figures on the keyboard to subtract them out from the lower dials as a check before going on with the work. If the amount has been correctly set up on the keyboard, zeros only will appear in the lower dials after the subtraction. This safeguard prevents transposition and other errors. Speeding up division. In registering a dividend in the lower dials, a figure 1 appears in the upper dials. This must always be cleared out before proceeding with the division. Instead of clearing this one out by means of the dials clear out crank, considerable time may be saved by clearing the keyboard and touching the minus bar. With no figures on the keyboard, this subtraction will remove the 1 from the upper dials without altering the dividend in the lower dials. The divisor may now be set on the keyboard and the operations of division started immediately. Shortcut multiplication. When a multiplier is a number containing 7s, 8s, or 9s, as for example, 39, 198, 997, the multiplication may be accomplished by a combined use of the plus and minus bars, reducing considerably the number of revolutions required by the regular method. Example, 2146x 198 equals 424,908. Set 2146 on the keyboard, shift the carriage 2 places to the right, and with the plus bar multiply by 2. In other words, multiply 2146 by 200. Then shift the carriage back 2 places to its original position, and with the minus bar, subtract 2. The answer, 424,908, will then show in the lower dials and the multiplier in the upper dial. In the left upper dials it will appear as 202, i.e., 200 less 2, and in the right upper dials in true figures 198. See figure 12. Solving this problem by shortcut multiplication required only 4 revolutions of the machine, whereas the regular method would require 18 revolutions. The operator should practice this method of shortening all multiplications. For example, instead of multiplying by 88, multiply by 100 and take off 12, showing the multiplier in the left upper dials as 112. Instead of multiplying by 2192, show this multiplier in the left upper dials as 2212. A little practice will enable the operator to become quite proficient in speeding up all multiplications by using cuts such as these. 283 shown in left upper dials as 323, in right upper dials 283. 408 shown in left upper dials as 412, in right upper dials 408. 827 shown in left upper dials as 1233, in right upper dials 827. 2791 shown in left upper dials as 3211, in right upper dials 2791. 5987 shown in left upper dials as 6013, in right upper dials 5987. The cumulative multiplication. The accumulated total of a number of multiplications can be obtained on the Monroe by making one multiplication after another without clearing the lower dials. Example, check the total number of articles and the total cost of the following invoice. 29 articles at $.49 each equals $14.21. 41 articles at 2.25 each equals $92.25. 58 articles at 1.89 each equals $109.62. 3 articles at 4.01 each, $12.03. Total articles 131. Total cost $228.11. Mark 2 decimal places on keyboard. Mark 0 decimal places on upper dials. Mark 2 decimal places on lower dials. Set upper dials control lever to left. Set 0.49 on keyboard and multiply by 29. Using shortcut multiplication, the result, 14.21, will appear in lower dials. Clear upper dials only with a single forward turn of the dial clear-out crank. Note the figures 29 are retained in the right upper dials. Next, set 2.25 on the keyboard and multiply by 41, using the left upper dials to register the multiplier. At the end of this multiplication, the left upper dials will show the multiplier 41, the right upper dials 70, the accumulation of 29 and 41, and the lower dials 106.46, the accumulation of the result of this multiplication and the result of the previous one. Continue in this manner each multiplication, in each case clearing upper left dials only and allowing figures to accumulate in the right upper dials and lower dials. At the completion of the last multiplication, the total number of article, 131, is shown in the right upper dials and the total cost, 228.11, in the lower dials, as in Figure 13. Figure 13. Taking off discounts, chain discounts. Example, 456 pounds of copper wire at 22 cents each per lb, less 50, 10, 5. Mark off 2 decimal places on keyboard. Mark off 3 decimal places on both right upper dials and left upper dials. Mark off 5 decimal places on lower dials. Set 456.00 on the keyboard and multiply by 0.225, starting with 5 and shifting carriage to the right. The result in the lower dials is 102.60000, the list value. The dials read, clear keyboard and upper dials only. Set the product, 102.60, on the keyboard and with the minus bar subtract 5 times, registering the 0.500 in the correct position in the left upper dials. Disregard figures in the right upper dials. This operation has taken off 50%. The dials now read, disregarding the right upper dials, left upper dials, lower dials, clear keyboard and upper dials only. Copy 51.30 from the lower dials to the keyboard and subtract once, registering 100 in the left upper dials. 46.1700 appears in the lower dials, being 50% and 10% off. The dials now read, clear keyboard and upper dials only. Set the 46.17 on the keyboard, shift carriage one place to the left and take off 5% by subtracting 5 times, showing 0.050 in left upper dials. Final result reads, $43.86 represents the net or total. Cost, $102.60, less 50, 10, 5. Use of tables for chain discounts. When there is any considerable work to be done in taking off chain discounts, it is of course advisable to use a table, which may easily be prepared, showing the equivalents of the discounts most frequently used in a particular class of work. Such tables, designed especially for the Monroe calculating machine, printed on cards, will be furnished upon application to the company. For example, the equivalent of 50, 10, 5 off is 0.5725 off, and the equivalent of 100% less 0.5725 is 0.4275. Knowing this equivalent, in the above example the same result may be obtained by simply multiplying the total cost, 102.60, by 0.4275. Example, the list price of a certain metal is $6.50 less 50, 10, 10, 5. What is the net price? Decimal setup. Keyboard 5 places, right upper dials, 2 places, lower dials, 7 places. Set the equivalent. 0.38475, taken from table of chain discount equivalents on the keyboard and multiply it by 6.50, showing the 6.50 in the upper dials. Read the answer 2.50 in the lower dials. Reciprocals. When the same divisor is used a number of times, division is shortened by multiplying each dividend by the reciprocal of the divisor. In other words, dividing one number by another is the same as multiplying that number by the reciprocal of the divisor. The reciprocal of a number is 1 divided by that number. For example, 1 divided by 5 gives the decimal equivalent 0.2, which is called the reciprocal of 5. Multiplying a number by 0.2 gives the same result that would be secured by dividing that number by 5, because 5 and 0.2 are reciprocals. Reciprocals are used extensively in percentage work and in prorating. They form the basis of decimal equivalent tables as used in payroll calculations, cost accounting, and many other kinds of mathematical calculations. Reciprocals commonly used. Common reciprocals used in different lines of business which may be memorized if they are used frequently are as follows. Month of 28 days 0.03571 144 gross, or inches to. Month of 30 days 0.03333 SQ, FT, 0.006944. Month of 31 days 0.03226 240 pence to a pound 0.004167. 32 pounds to a bushel 0.03125 360 days to a year 0.002778. 56 pounds to a bushel 0.01786 365 days to a year 0.00274. 60 pounds to a bushel 0.01667 1728 cubic inches to a foot 0.00587. 12.08333 2240 pounds to a gross ton 0.00044464. 16 Oz, or 16.0625 5,280 feet to a mile 0.001894. Tables of reciprocals 1. 10,000 are published by various authors, but their use with the Monroe is unnecessary as reciprocals can be run off on the machine more rapidly and accurately than they can be looked up in tables. Monroe method of finding reciprocals. With the Monroe, the finding of a reciprocal of any number is a simple problem of division. Problem. Wanted the reciprocal of 144 to 6 decimal places. Move the carriage to the right as far as possible. Since the reciprocal of 144 is 1 divided by 144, prefix a 1 to 144 and set on the extreme left of the keyboard. Turn the 1144 into the lower dials by touching the plus bar. Then by means of the 0 clear key of the last column of keys clear the I from the keyboard. The machine is now as shown in figure 14. Without clearing the 1 in the left upper dials, divide, carrying the division out as far as desired. Note the first reverse revolution of the machine in this division clears the 144 in the lower dial and the 1 in the upper dials so that in reality 1 is divided by 144. The result of this division, the reciprocal of 144, appears in the left upper dials. The rule which determines the decimal point in reciprocals is as follows. Prefix as many ciphers to the reciprocal as there are whole numbers less 1 in the original number. The figure 144 having 3 whole numbers requires 2 ciphers. Therefore 2 ciphers are added to its reciprocal, 0.006944. Prorating or distribution. In the following problem, the total mileage of 3 divisions of a railroad and the combined receipts of these divisions are given, it being required to obtain both the percentage and the amount to each division. First add the mileage of the 3 divisions and obtain the total mileage, 803. Then obtain the percentage due to each division. This may be done either by dividing the mileage of each division by 803 successively or by using the shorter reciprocal method, as follows. Obtain the reciprocal of 803, which is 0.00124533. Mark off 8 decimal places on keyboard, mark off 0 places on upper dials, mark off 8 places on lower dials. Set 0.00124533 on the keyboard and multiply by 423, the mileage of division A, getting in the lower dials a result of 0.526775, percentage due a do not clear keyboard or dials. By means of the plus and minus bars, change the multiplier to 234 in the right upper dials, getting in the lower dials 0.291407, the percentage due be again changing the multiplier in the right upper dials to 146, the result 0.181818 is obtained. Percentage due C. Set these percentages down as they are obtained as shown in the 4th column above. It is now required to prorate the total receipts 9,684.75 in the ratio as shown by the percentages. Mark off 2 decimal places on keyboard. Mark off 6 decimal places on right upper dials. Mark off 8 decimal places on lower dials. Set up 9,684.75 on keyboard, and using the percentages just found as multipliers, turn them out in the right upper dials, setting down the amount to each division as shown in the 5th column above. After the last amount 1,760.862 is obtained, leave it in the lower dials and add to it the other 2 amounts to check back to the total 9,684.75, thus proving the work in the problem is worked out. The figures have been carried out sufficiently far to obtain the result correct to a cent. In many cases it is only necessary to obtain results correct to the nearest dollar. In the latter case the work may be considerably shortened by using only 4 decimal places in the percentage column instead of 6 places. If it is required to find only the amounts due each division, and not the percentages, the work may be considerably shortened by the following method. Find the receipts per mile by dividing the total receipts $9,684.75 by 803. This gives $12.06 as the receipts per mile. Set this up on the keyboard as a constant, and using the respective mileages as given in the first column as multipliers, turn them out in the right upper dials and obtain the amounts due each division directly as shown in the 5th column above. Interest. Interest may be figured by the ordinary arithmetical rule as follows. Multiply the principal by the rate. Then multiply this total by the number of days and divide the total thus obtained by 360 or 365 as the case requires. There are, however, many ways of handling interest calculations on the Monroe, all of which are shorter. Since the rate of 6% and a 360-day year are generally used in figuring interest in most businesses, the Monroe 6% method is given here. This method of figuring 6% interest on a 360-day basis is as follows. Determine the amount of interest on $1,000 for the required number of days by dividing the number of days by 6 and multiply by the principal expressed as a decimal of thousands. For this work it is well to memorize the decimal equivalents of sixths. Example, find the interest on $3,575.25 at 6% for 47 days. Mark off 5 decimal places on keyboard. Mark off 3 decimal places on right upper dials. Mark off 8 decimal places on lower dials. Mentally divide 47 by 6. The result, 7/5/6, expressed as a decimal is 7.8333. This is the interest on $1,000 for 47 days. Set 7.8333 on the keyboard and multiply by the principal, 3,575.25, expressed as a decimal of thousands by changing the decimal point 3 places to the left, giving 3.575. The result, 28.00, in the lower dials is the interest. Build-up division. Division is often accomplished more rapidly when the build-up or multiplication method is used. This is a method which is particularly efficient in the division of large numbers or where a constant divisor or dividend is being used. The divisor is set on the keyboard and the dividend is built up in the lower dials by a series of multiplications. The quotient appears in the right upper dials. Example, 7955 to 25, 318.2. Mark 0 decimal places on keyboard. Mark 1 decimal place on right upper dials. Mark 1 decimal place on lower dials. Set 25 on the keyboard and shift the carriage to the right until the 25 is directly under the lower dials in which the 79 of 7955 is to appear. By means of the plus bar, add in the divisor, 25, until the lower dials show a number as near 7955 as possible without exceeding it. Perform this in the following manner. Shift the carriage into the 4th position and depress the plus bar so that the machine makes 3 forward revolutions. The lower dials then read 7500.0. This is as much as 25 can be added into the lower dials in this position without obtaining a number greater than 7955. Therefore, shift the carriage 1 place to the left and proceed as before. 1 forward revolution makes the lower dials read 7750.0. Again, shift the carriage 1 place to the left and continue building up by means of the plus bar. 8 revolutions and the lower dials read 7950.0. As near as 7955 can be approximated in whole numbers. By shifting the carriage once more to left and adding in divisor twice, the lower dials read 7955.0, the required number. The quotient 318.2 appears in the right upper dials. When the build-up division is completed, the divisor, dividend, and quotient all appear in the machine as shown in Figure 15. In building up a dividend in this manner, the operator must always keep below the required dividend. That is, whenever the number in the lower dials becomes larger than the required dividend, the revolutions of the machine should be reversed by the minus bar, and the carriage shifted to the next position. With this Series 3 Monroe, this build-up method of division is very speedy because of the tens carry mechanism of the right upper dials. In building up the dividend, when a number is obtained in the lower dials that is greater than the dividend desired, the carriage is shifted immediately to the left, and in the next position with the minus bar, subtractions are made until the figures equal or approximate the required number. Simultaneous multiplication and division. Much time can be saved by multiplying the quotient of a division at the same time the division is being made. Multiplication and division are performed simultaneously by building up the dividend at one end of the lower dials, using build-up division, and multiplying the quotient which is being obtained by another number set up at the other side of the keyboard. Example, 1728 pieces at 26 cents per dozen. Find number of dozen in total cost. For problems of this kind, 2 sets of decimal points are required on the keyboard and lower dials. Mark off 2 decimal places on right upper dials. Mark off 0 and 8 decimal places on keyboard. Mark off 2 and 10 decimal places on lower dials to correspond to the 2 keyboard decimal places plus the right upper dials decimal place. Set 12 on the extreme right of keyboard. Set 0.26 on the extreme left of keyboard. Keyboard now reads 0.26000012. Ignoring the 0.26 on the left, by means of the plus bar, build up 1728.00 in the lower dials from the 12 on the keyboard as explained on page 29. At the completion of the operation, the dials read. The 144 obtained in the right upper dials by the building up process of division represents the quotient or number of dozens in 1728. The 37.44 represents the product of 144 times 26, or the total cost of 144 dozen. This method is practical when the numbers involved are not so large as to make the amounts built up in the lower dials run together. Complementary division. Complementary division is more practical when simultaneous operations involve large numbers. Complementary division is subtraction division accomplished by adding the complement of the divisor. The dividend is put in the lower dials. The complement of the divisor is set on the right of the keyboard and the multiplicand less 1 on the left of the keyboard. 1 or more 9 keys are depressed on the keyboard to connect the two factors. The number set on the left of the keyboard is always less 1 than the actual multiplicand and is connected by 9s with the complement of the divisor set on the right of the keyboard. The reason for doing this is that each forward revolution in complementary division carries over a 1 from the dividend. By having the 9 keys depressed, this I is automatically carried over from digit to digit until it finally is added into the figures of the result of the multiplication which is being performed simultaneously. 1 is dropped from the multiplicand set upon the left of the keyboard to allow for this. The complement of a number is the difference between that number and the next higher power of 10. Thus the complement of 6 is 4, of 12 is 88, of 73 is 27, of 28 is 72, of 21 42 is 78 58, etc. To obtain the complement of a number mentally, subtract the right-hand digit from 10 and the others from 9. To find the complement of any number on the Monroe, put the number on the keyboard and subtract from ciphers in the lower dials by a touch of the minus bar. The number in the lower dials to the right of the 9s is the complement of the number on the keyboard. Using the same example of 1728 pieces at 26 cents a dozen. Mark off 2 decimal places on right upper dials. Mark off 0 and 8 decimal places on keyboard. Mark off 2 and 10 decimal places on lower dials. Set 1728 on the keyboard and turn into the lower dials in the proper position with regard to the decimal point. 1728.00. Clear upper dials and keyboard. At the extreme left of the keyboard, set 0.25. 25 represents 1 less than 26 cents. At the extreme right of the keyboard, set 88, the complement of 12. Connect the two factors on the keyboard by depressing the 9s. Shift the carriage so that the figures 17 of 1728 in the lower dials are directly in line with the 88 on the keyboard. Now divide 12 into 1728 by depressing the plus bar. After one forward revolution, the dials will read. As the result of the division of 1728 by 12 is being obtained in the right upper dial, that result is being multiplied by 0.26 at the left in the lower dials. As 12 will not be contained in 5, shift carriage to the left 1 place. After 4 forward revolutions in this position, the dials are as follows. Further forward revolutions cannot be made in this position without bringing up 9s over the 88, which would indicate the operation had gone too far. Therefore, shift carriage to the left, continue as above. This gives the same result as in the previous example, that is $144,037.44 total cost. By this method, the 1728 is being cleared out as the other numbers are being built up, and therefore the numbers can never run together. Whenever too many forward revolutions are made in any position, 9s will come up in the lower dial, and machine must be reversed by means of the minus bar to correct. This same method of simultaneous multiplication and division may be applied to various kinds of calculations, as for example, find the number of tons in total cost of 5197 pounds at $25.25 per long ton. In this example, the capacity of the keyboard is not sufficient to set up the complement of 2240, the connecting 9, and the 2524. Therefore, set up 776 at the right, dropping the cipher 25.24 at left, and connect by the 9. The machine then reads the right upper dials and $58.58 total cost in the lower dial. Thus, the Monroe Company publishes many interest and other decimal equivalent tables which further help to shortcut and simplify certain types of figuring jobs. Also, special instructions for applying the Monroe Adding Calculator. These are furnished free to users and operators. Of the many Monroe publications, the few listed below are those most generally used in ordinary commercial figuring. Any that might be useful in your line of work will be gladly furnished by the nearest local office of the Monroe Calculating Machine Company, Inc., or by the main offices, which are in Orange, New Jersey. Requests should mention form numbers. Thank you for listening to today's snoozecast. Sweet dreams.